In lesson 7, we're going to continue our work with proofs and parallel lines. So in our first one, we're given that BD is parallel to AE, B is the midpoint of AC, and angle 1 is congruent to angle 2. And we want to prove that D is congruent to E. So it's usually a pretty good giveaway that we are going to be working with CPCTC at some point. So in that case, we're going to try to prove those two triangles are congruent. So we've got BD parallel to AE. We have B is the midpoint of AC, and then we have angle 1 is congruent to angle 2. So since that one is all done for us, I'm going to mark that one and I'm going to move on. Next piece is our parallel part. Normally with parallels we look for alternate interiors, but they don't actually exist in this picture based on our two parallel lines. So what we want to work with is the fact that we've got 3 and 4 as our corresponding angles. So angle 3 is congruent to angle 4. Parallel lines form congruent corresponding angles. So remember, we always look alternate interior first, then corresponding next. I'll move on to my midpoint piece. The fact that B is the midpoint tells us that we have AB is congruent to BC. A midpoint divides a segment into two congruent segments. Now if I look at what I have in my pictures, I have angle, side, angle, and angle, side, angle. So therefore my triangles are going to be congruent. I have triangle AEB is congruent to triangle BDC. Angle, side, angle. And then that makes my last piece that angle D is congruent to angle E, congruent by CPCTC. So prove the two triangles congruent, angle, side, angle, and then we can state CPCTC gets us angle D congruent to angle E. In number 2, in the following diagram, AB is parallel to DC, and then they give us AD is parallel to BC. So they give us top and bottom are parallel, and then left and right are parallel. So the first thing they ask is they just want us to state what angles are going to be congruent and the reason. So we're going to end up with angle 2 being congruent to angle 4. And then we're going to end up with angle 3 being congruent to angle 5. And both of those are going to end up being congruent by the same exact reason, and that would be parallel lines form congruent alternate interior angles. So now if they want us to prove that these two triangles are congruent, we're going to start our chart just the way we normally would, and we're basically just going to use that information and maybe a little bit more to get that those two are congruent. So our givens for this piece are going to be the two parallel pieces. So AB parallel to CD and AD parallel to BC. So both of those are going to be our givens. And then the statement we just went with up there is what we're going to work with again. So we're basically just going to take what we wrote up top and we're going to move it down a step. Angle 2 is congruent to angle 4, and angle 3 is congruent to angle 5. Parallel lines form congruent alternate interior angles. So that's all of our givens. Now we need to find something else in our picture. Well, if we look at our two triangles, we have two angles in each, but we also have our reflexive piece. So step 3, BD is congruent to BD. Reflexive property of congruence. Now let's look at our picture. We have angle, side, angle, and angle, side, angle. So therefore, we have our congruent triangles. Step 4. Triangle ABD is congruent to triangle CDB by angle, side, angle. So 2 sets of alternate interior angles followed by a reflexive piece gets us our congruent triangles by angle, side, angle.